Good morning, friends. Welcome back to Brain Sizzlers. Today, we are going to continue with our percentages topic. In particular, we are going to deal with rise and drop by same percentage. So, the topic goes like this: resultant percentage change when a particular fixed quantity is increased by a fixed percentage, and then from the resultant, it is again decreased by the same fixed percentage. Now, at hindsight, it might look a bit high sounding or far fetched, but it is not so. It's quite simple. Let us consider with an easy example. See, if we are considering two quantities, namely 120 and 150, we use the direct proportion logic that we used to study in elementary school level. So, if 120 is given a yardstick of 100, 150 will be found equivalent to 125. So straight away we can find that there is a rise of 25%. That means from 120 to 150 there is a rise of 25%. Now if we consider the same drop of 25% from 150, what will be the new value? So for 100 it is 25, for 150 it amounts to, applying the same DP logic, it will come to 37.5. So when we subtract this 37.5 from 150, we are getting a value of 112.5. This value seems to be slightly lower than our initial value. In fact, it is. So the initial value that we considered was 120. When it got raised by 25%, we attained a value of 150. Again, when we drop by 25% from 150, we are attaining a value 112.5, which is slightly lesser than our initial value 120. Now it is nothing but 112.5. Now if 120 is given a yardstick of 100, what will be 112.5? It will be 93.75%. So straight away the resultant percentage change is nothing but a drop of 6.25%. Now let us frame a mathematical relation. Let the initial value be y, let the percentage increase be x. So when we increase a value by percentage x, for 100 it is x, for y the absolute quantity that is being raised will be yx by 100. So simply add this yx by 100 term to the original value y. So y plus yx by 100 gives our new value. So the 150 that we saw in our example, from 120 we raised to 150, from y it is getting raised to this new value 100y plus yx by 100. Now if we drop this value by x percentage, what happens? Let us see. For 100 it is x, for 100y plus yx by 100 we are getting some value that is nothing but 100yx plus yx square by 100 square. This is the drop in value. So this value has to be subtracted from the new higher value that we have obtained. So we are subtracting it. After subtracting we are getting this value. So in comparative exams there are threefold equations which can be utilized effectively. For example, if we are given some random value 240 or 250, and if 240 or 250 is raised by some 30%, and again from the resultant it is dropped again by 30%, what will be the new value? If the question is asked like that, straight away we can use this formula: y into 100 square minus x square by 100 square, where y is our initial value. So it is quite obvious that 100 square minus x square will give a value which is less than 100 square. So this term 100 square minus x square by 100 square will give a value which is less than 1. So any fraction which is less than 1 multiplied with some quantity will give a quantity less than the original quantity. That is quite obvious. So we will obtain a new value which is lesser than the original value. This we saw in our example also. From 120 we got a lower value which was 112.5. Now when new value is expressed in terms of initial value as a percentage, so when y is considered equivalent to 100, percentage of new value with respect to the initial value will be 100 square minus x square by 100. This again is obviously less than 100. So this formula can also be quite useful in the competitive exam. Suppose when we are given when we are not given a quantity, we are being asked that when some quantity is raised by 40 percentage and again from the resultant it is dropped by 40 percentage, what is the percentage of the new value with respect to the initial value? If the question is asked in such a fashion, we can straight away employ this equation and get the required answer. This is the second important equation, and the final and the most important equation that is quite often asked in CAT and other competitive exams is this one. So what is the drop in percentage? Drop in percentage is 100 minus this value that we have shown here in equation 2, that we have to utilize here. So 100 minus of 100 square minus x square by 100 will give us a value of x square by 100. This is a paramount prominence. See, let us compare this equation and make utilize of this equation in our example that we considered initially. Let us come back to our original example. In our original example, we considered the value 120 and 150. Let us for the time being forget 120 and 150. Suppose if we are asked that when a quantity is raised by 25% and from the resultant it is decreased by 25%, what will be the net drop in percentage from the initial value? For that, we can straight away use the shortcut formula x square by 100. The percentage drop from the initial value will be equal to x square by 100. In this case, it will be 25 square by 100. That will amount to 6.25%. So all these three formulas, namely given by equation 1, 2 and 1 followed by 2 followed by 3, all these three will be quite useful for the percentages calculation in competitive exams. Thanks a lot for watching patiently.